picking up from where we left last time, the only changes I've made to our code is pass in the entry point class and self to the superconstructor function to ensure correct MRO or method resolution order. Our application can be divided into 5 distinct operations. 1. Receive input. 2. Return output. 3. Allow the user to edit their input. 4. Clear both their input and output. And finally 5. Be able to toggle between light and dark themes. The BTN class handles 3 of the 5 operations. That said, you'd realize that we need a way to be able to access the MD text field and the MD label from the BTN class. So how do we go about it? So just like we were able to access the grid layout from the .kv file, that's the same method we're going to use to access the MD label and the MD text field from the .py file. So I'm going to define 2 variables, the text label whose value is set to object property class, because just like the grid layout, an MD label is a class, and a class is an object that has data and method attributes. So the text label is going to represent the MD label because its ID is set to text label, and we have defined the same property up here. I'm also going to define another variable, text field, and set its value to object property. This is going to represent the text field. We are now able to access the text label and the text field from the .py file, but that is not all. We need to be able to pass the 2 variables to all the instances of the BTN class. And how do we do it? By passing these variables as parameters to the instances of the BTN class. And with that, we have passed the MD label and the MD text field as parameters to all the 19 instances of the BTN class. Switching to the BTN class, we need to define a constructor function so that we can be able to capture the text field and the MD label from the BTN class. So I'll just do that. And in here, I'm going to pass 2 parameters, text field to represent text field and text label to represent the text label. After that, I'm going to define 2 variables, self.textField to hold the text field and self.textLabel to hold the text label. I am not good at typing and talking at the same time. And now we are able to access the text field and the MD label from the BTN class. Now every button in QV and QVMD has the onRelease method. Now this method captures the onRelease event that is fired when a button is clicked or touched and then released. So we want that each and every other time a user clicks a button and releases, the onRelease event is fired and we're able to perform specific operations. So let's define this method, onRelease. Earlier, we said that the BTN class handles 3 of the 5 operations. That is, allows a user to edit their text, pass in their text, and clear both their input and output from the application. Now, to clear input and output from the application, we are going to use the CBTN. To edit inputs, we are going to use the chevron left BTN. And to be able to pass input, we are going to use the remaining 17 instances of the BTN class. So using an if statement, let us split the operations into 3. I'm going to say if self.icon is the same as is equals to chevron left. Inside this if block, we're going to handle editing input. And then I'm going to also include an elif and say that if the icon value of whatever instance is equals to alpha C, inside here we are going to clear both the user input and user output. And then I'm going to pass an else statement. This is going to handle the remaining operations of the 17 instances of the BTN class. Now, we need to be able to get the value associated with each instance of the BTN class, and that is doable because we have associated each icon with a value, and we know that to be able to get the value of a key in a dictionary, we use the slice literal to pass in the key so that we can be able to get the value associated with that key. So to get the value, I will define a new variable and call it txt, and I'm going to set it to a string. Why am I setting the value of the txt variable to string? Because when, for example, a user clicks 7, we need to pass this 7 to the text field, and we know that text property of the MD text field accepts only string values, because as we can see, we have very different values. We have integers, we have this, and then we have strings. So we need to be able to convert them into strings before we can access them. So after converting it into a string, I'm going to get the value associated with each key. To achieve this, I'm going to pass in the value of the icon attribute of the BTN class as a key to the icon dictionary. And with that, we're able to get the value of any instance of the BTN class. Let's just print the value and see what we're getting. So for 7, we should get 7 on the terminal. And there we have it. We have 8 division everything is working as expected. After associating each key with a certain value, we want to be able to add this value to the text field. And because the operation associated with passing input to application is handled in the else block, we are going to get the text field, and we are going to get its text property and add the txt value to it. Let's see if this implementation works. So I'm just going to pass 7, 8, 9. So we are able to pass input into our calculator. After passing inputs, the next is being able to clear the screen, and clearing both the input and output is handled by this if else block. Now, when a user clicks the alpha C, we want to clear the self.text field. We are going to set that to empty, and self.text label, we are also going to set that to empty. And with that, we are done with 2 operations. We are able to add input to our application, and we are able to clear both input and output from the application. So let's test it out. So I'm going to add 7, 4, maybe plus 63. And when I press the EqBtn, the input needs to be cleared. We don't have the output yet, but the input needs to be cleared. So let's try it out. And it's not working. Oh, so the reason is we have to, what are we clearing actually? We are clearing the text property of the text field, and we are clearing the text property or the text attribute of the MD field. Sorry about that. Let's try it out again. So I'll say 78 times maybe 96. When I press the C button, the input and output, which is not currently available, needs to be cleared. And there we have it. We have handled 2 of the 3 operations. So let's go to the third operation, and that is being able to edit the user input. The implementation for this is a little bit different because we have 3 scenarios, okay? So let me pull up the calculator and show you the 3 scenarios that I'm talking about. Say, for example, this is our input. This cursor can be placed at 3 specific points within the input. At the start of the input, at the end of the input, and anywhere within the input. So we need to be able to handle the 3. Say, for example, when a user places the cursor at the start of the input, we have nothing preceding the cursor. So we need to be able to delete whatever comes after the cursor. So in this case, 7. But if the cursor is within the start and the end of the input, we need to be able to delete the element that comes before the cursor. So in this case, 2. And finally, we need to also be able to handle this scenario where we have no input passed in. When I click the chevron left icon button, nothing happens. Now, let's get back to our code. Inside the if block, we need to handle 3 scenarios. We're going to break these 3 scenarios into 3 if statements. So the first is, we're going to check if the self.text field.text is empty. If not, self.text field, if it's empty, this will return true. If that is true, we just want to return. So we're going to return control back to the onRelease method. If that is not the case, we need to be able to locate the cursor. Conveniently, the MD text field has the cursor index method. And with the cursor index method, we are able to locate, or we are able to retrieve the position of the cursor within the input of a text field. Let's create a new variable. I'll call it cursor. And I'll set its value to self.text field, and we're going to get the cursor index. Now, let us print the cursor so that we can see exactly what we have. So I will just print cursor, and then I'm just going to pass in a few inputs. And as you can see on the terminal, the position of the cursor is returned to us. We are going to leverage this function to be able to appropriately edit the input. The second condition that we are going to check inside this if block is if, for example, let me pass in a few inputs. So if the position of the cursor is at the farthest end, this is the start and this is the end, because we have changed the base direction to right to left. If this is the case, I'll say elif the position of the cursor equals to the length of the self.text field.text, we need to be able to perform a specific operation when this evaluates to true. Let me pull up our application again so that I can explain something. Let me pass in a few values again. At this point, our cursor is at index 0. This is 1, this is 2, this is 3, this is 4, 5, 6, and 7. At this point, the index of the cursor is equal to the length of the entire string. This is the condition that we're handling inside this elif block. You'll see that when a user clicks the chevron left button, the element that is immediately behind the cursor is removed from the input. To implement that, I'm going to say self.text field, text, we are going to assign it a new variable. And the reason why I'm assigning it a new variable is a string in Python is immutable. That means we cannot directly edit a string variable unless we assign it a new value. So I will assign it to self, the text field, the original text in the text field, but this time round we're just going to remove the last character. So in this case we just want to remove 3 from the input. And how are we going to achieve that? By using slicing. I'm just going to tell Python, assign the text property of the MD text field, everything except the last element. And with that, we have handled the second scenario. But what if the position of the cursor is somewhere else, is in between 0 and the last index of our input? So that is what we are going to handle in the else statement. So let me bring back our calculator again for reference. So if I pass in a few inputs, we want to be able to remove the element that is directly behind the cursor. So in this case, 8 is behind the cursor, and when we press the chevron left icon button, 8 is going to be removed, 6 is going to be removed, the multiplication sign is going to be removed. Let's handle that. Now in here, because we're directly editing our input, what I will do, I will convert our input into a list. So I'll just define a new variable list, okay, and I will wrap our input inside the list function. And with that, we will have converted our input into a list. We're going to check the position of the cursor within this input. The cursor can be in 2 specific positions. Let me bring back our application. Now, the first position the cursor can be is when the cursor is greater than 0. At this point, the index of the cursor is at 0. And at this point, the index of the cursor is greater than 0. If this is the case, we want to be able to delete elements that are immediately behind the cursor. In this case, 8, 4, and 7. You'd realize now that the position of the cursor is 0. What do we want to do when the position of the cursor is 0? We want to delete elements that are directly in front of the cursor. So in this case, 5, 8, and 4. Let's implement that. I will check. If the position of the cursor is greater than 0, okay, that means that the cursor is in between the text. We want to be able to remove the element that is directly behind the cursor. We will take our list. Because list is mutable, I don't have to create a new variable. I'll access this list variable and I'm going to call the pop function. The pop function takes an index, and because we want to remove the element that is behind the cursor, I'm going to pass in the index of the cursor, but I'm going to subtract it by 1. I hope that is clear. Just a recap, let me pull up our calculator again. Let me pass in a few values in here, and I'm saying that when the position of the cursor is greater than 0, because at this point the index of the cursor is at 0, at this point it's at 1, 2, 3, 4, and 5. And at this point, the index of the cursor is equal to the length of the entire input. When the cursor is greater than 0, we want to be able to delete an element that is directly behind the cursor. In this case, 8 is at the same index as the cursor, and 7 is 1 index behind the cursor. That is if the cursor is between 7 and 8. So this if statement is able to handle that scenario. But what if the position of the cursor is equal to 0? At this point, the position of our cursor is equals to 0. Because we have no elements behind the cursor, we're going to delete elements that are directly in front of the cursor. So we are going to say, if the position of the cursor equals to 0, okay, what do we want to do? We want to remove elements that are at the same index as the cursor. So we'll say lst.pop elements that are at the same index as the cursor. After that, we need to be able to reconstruct this list back to a string. So to do that, I'm going to assign the text property of the text field a new value. I'm going to use the join method, the join string method, which takes an iterable and then reconstructs it back to a string. The parameter or the argument that I'm going to pass here is going to be the list. Let's try it out and see what we're getting. I'll pass in a few values. At this point, this first if statement evaluates to true. 8, which is directly behind the cursor, is going to be deleted. So let's try it out. Something strange has happened. Instead of deleting 7, our cursor resets back to the default index, which is equals to the length of the entire input. But that is not what we want. To fix this, we need to be able to ensure that the cursor does not revert to its original index. And to do that, I'm going to set the position of the cursor at the same position as it was initially. I'll say self.textfield.cursor, because it has a cursor, and this cursor property takes in 2 values, one for the position of the cursor in the x-axis and one for the cursor in the y-axis. But because we are only dealing with a single line text and not a multi-line text, we're just going to say that after each edit, the index of the cursor is going to be the index of the element directly behind it. So I'll say reset the position of the cursor to cursor -1, and for the y, I'm just going to set it to 0 because we are using a single line text. Let me bring our application back to explain exactly what I mean. Let me pass in a few inputs. when the cursor is between 8 and 7. If we don't reset the position of the cursor, what is going to happen after deleting 8, the cursor is going to go back to its default index, but we want it to stay here. The cursor needs to replace the index of 5. So that is basically what this line is doing. Now that we have that done, let's test that out to ensure that everything is working fine. So I'm going to pass in a few values, 7, 8 divided by 9, 6, plus, minus, multiply, and then I'm like, no, I accidentally added a multiplication sign, so let's remove it. When I press the chevron left button, the position of our icon does not change. But what if after removing the division sign, I want to add operands and operators at this point? So let's add that and see what we get. You see, when I add new operands and operators, instead of these operands and operators being added at this index, despite the fact that the cursor is at this point, they are added at the default position of the cursor. So we need to be able to also handle this. And where we're going to be able to handle this is in this else statement, because this is where we are adding new inputs into our calculator. Just like we did in this else block, we know very well that a string is immutable. So we cannot actually directly edit it unless we define a new variable that is going to reflect the new changes. Now, instead of directly adding to the text property of the text field, we are going to create a new variable, lst, and we are going to deconstruct our text into a list. So I'll say self.text. After that, we need to be able to add to this list at the position of the index. So we'll say lst.insert, and as you've guessed it, we're going to pass the index of the cursor, the value of the txt, the value associated with each icon. So irrespective of where the cursor is, we're just going to place new elements where the cursor is. After that, we are going to reconstruct this list back to our string. So we'll say self.textfield.text equals to join. We're going to use the join method, and we're going to pass our iterable list. Remember that immediately after the changes are made, by default the cursor returns back to its original position. But this is not what we want. We want to ensure that the cursor stays at the position where the user placed it. Now, because we're adding new elements to the text field, okay, we are not adding elements behind the cursor, but we are adding elements at the position of the cursor. To be able to do that, we're going to ensure that after each insert, the cursor maintains its position. Text color, really, text field dot cursor equals to cursor plus 1, because during the edit we set it to cursor -1. Now we have to return it back to the position where the user has placed the cursor. For the Y, because we are working with a single line text, not a multi-line text, we're going to set the position of the cursor in the Y axis to 0. And with that done, we have completed 3 of the 5 functionalities that our application is going to handle. Let's test our code to ensure that everything works as expected. So I'm going to pass in a few inputs. I'll pass in 7, 8, 5, maybe -98. Okay, and say at this position I want to add new elements. I want to add 1, 2, 3, and as you can see, our input is added at the point where I have placed the cursor, just like the user would want. What about deleting? Right, we are able to correctly delete inputs from the text field, and when there are no more elements behind the cursor, we are going to delete elements that are in front of the cursor. So let's test that out. So 5, the subtraction, 9 and 8. Perfect. And finally, when the text field is empty, we don't want to do anything. If we don't handle this, our calculator is going to crash. In the next video, we're going to handle the functionality where our application is able to return an output back to the user when the equals to button is pressed. Until then, happy coding.